We're going to have to solve this rational equation. And when you solve any equation, your first goal should be to get x out of the denominator if it's there. So definitely got a bunch of x's in the denominator. And one thing you want to look for in these problems is see if you can factor one of the denominators. Like this is a trinomial we can factor, right? It's a trinomial where a equals 1, which means we can jump right to making the parentheses. That's 3 over, I'm going to start with an x in each parentheses, because x times x will make that x squared. And then we need two numbers at the end that will multiply to be 2 but add up to be 3. So x plus 2 and x plus 1. 2 times 1 makes 2, and then 2 plus 1 is going to make 3. So we factored the denominator here. And look, they set up the problem so that it works out perfectly so that we can just multiply everything by this common factor. So what you want to do is multiply this whole equation by x plus 2 and x plus 1. And the reason why we're doing that, here, forget about this, we rewrote it as this over here. The reason why we're multiplying everything by this in red is because the denominator will cancel out here, the denominator will cancel out here, and this denominator will definitely cancel out because we're multiplying it by itself. So when you multiply this red term to this first term in the original equation, the x plus 1 and the x plus 1 cancel out. You have an x plus 2 that still needs to multiply to whatever's left over. So we're going to write the original numerator, but then it needs to be multiplied by what's left over after you cancel everything out, by the x plus 2. And no more denominator, right? Because that canceled out over here. And you got to do the same thing over here. You got to multiply this. The x plus 2's will cancel out. We still have an x plus 1 that needs to multiply to everything. We're going to write minus 3 and then a parentheses x plus 1. And then that equals x plus 2 times x plus 1 multiplied to this. They all cancel out and leaves us with just 3. Okay, and it's getting to be a more simple equation. We just got to multiply these, use the distributive property here. So we get negative 5x squared minus 10x plus 4x, so that's minus 6x when you combine like terms. Like I did, negative 5x times 2 makes negative 10x, and 4 times x makes 4x. Negative 10x plus 4x makes negative 6x. Feel free to take out a piece of paper and do FOIL, multiply that out off to the side if you weren't able to see what I did. And then distribute that negative 3. I actually had to remake this entire video because when I distributed, I just wrote minus 3 and not minus 3x. So went a little too fast. So make sure you take your time when you're doing it so you don't have to redo everything like I do. Okay, so we got everything distributed. Now we can combine like terms. Nothing to combine with the x squared term. Minus 6x minus 3x makes minus 9x. And then 8 minus 3 makes 5. And then it's quadratic, so let's set it equal to 0 by subtracting 3 from both sides. And I don't like my leading term to be negative, so I'm going to multiply every term by a negative 1, so it's a balanced step. You don't necessarily have to do that, but because now when we factor, we want to find two numbers. This is the longer method of factoring. If you have trouble with factoring quadratics, you'll want to Google search factoring when the leading coefficient is not 1 or something like that. Okay. This is the trinomial that we can factor, but we need to multiply the first and the last term. And so our goal is to find two numbers that multiply to be negative 10 but add up to be positive 9. So real quick, it's positive 10 and negative 1. Because positive 10 times negative 1 makes negative 10. Positive 10 plus negative 1 makes positive 9, so that checks out. And what you're doing with that pair of numbers is you're replacing the middle 9x with 10x minus 1x. So it's the same expression on the left. Now it's just set up to factor by grouping. We put parentheses around the first two and parentheses around the last two terms, and we factor out what's in common. I can take a 5x out of the first parentheses, and I can take out a negative 1 from the second parentheses. And now they both have an x plus 2 in common, so I can factor out an x plus 2, and then 5x minus 1 is left over. And if you set each of these factored pieces equal to 0 to finish solving, the first one, you're going to get x equals negative 2. If you do the same thing with the second one, add 1 to both sides, divide by 5, so we get 2 solutions. But look, if you were to try to plug negative 2 back into the original equation, you'd get a divide by 0 error. So we actually have to exclude one of our solutions. There's only one answer. X equals 1/5.